Wait, who is that Pokemon? Pokemon has become a pop culture staple, now with 9 generations of games and many more spin-off projects, such as shows, movies, and trading card games. There are now over 1,000 different Pokemon, and there will likely be more on the way. Beginners to Pokemon may feel overwhelmed or intimidated, especially as knowing a Pokemon's type is crucial for building teams and battling opponents. Some types are intuitively easy for people to guess based on design.
这个 Pokemon 是哪个 type?
水系的
while others are often less so.
这个 Pokemon 是哪个 type?
鬼
Add on the fact that some Pokemon also have secondary types, and it becomes a confusing guessing game for everyone. Luckily, our neural net is designed to classify Pokemon by both primary and secondary type to help overcome this struggle. Here's the general architecture of our neural network. But to train it, we have to first collect, then pre-process our data. I'll pass it on to Jesslyn and Aaron to explain just how we did that.
Next, we're going to talk about how we collected all of our data. Our primary source for images was GitHub and Kaggle. There were open source data collected by other individuals from in-game sprites as well as 2D artwork. We decided to code algorithms that combined all of the collected images under folders split into the different types so that we can load them easily when training. And in addition, we manually collected our own data from other websites in order to ensure that we achieved a balanced data set under all different Pokemon types.
Once we collected all of our Pokemon images, we realized that our dataset was wildly unbalanced among all the different types. If you think about it, this actually makes a lot of sense considering there are only 3 Pokemon with flying as their primary type, where there are 114 Pokemon with water as their primary type. To balance our dataset, we duplicated some images and augmented all of them to increase the number of samples in the less populated classes. For some classes, we even had to look for additional images on the internet because we didn't want to duplicate too many times in case our model began overfitting. In terms of processing these images, we first removed any alpha channels and then resized them to 224 by 224 pixels. We then did augmentation by adding in some random flips, rotations, and color jittering. Next, the images were sent through a pre-trained network called AlexNet to extract their features, and then finally, we can put them through our own CNN.
Our Pokemon type image classification project employs transfer learning as well as a CNN model. We use AlexNet to extract features, then these tensors are fed into our CNN model for training. Throughout this project, we have tried many different models, while changing factors such as number of convolutional layers, number of neurons, adding dropout, and much more. We found that the best model comprises of 2 convolutional layers for hierarchical representation, followed by 2 fully connected layers responsible for classifying Pokemon into their respective types. We classify the input picture into one of 18 or 19 classes, depending on whether it's categorizing primary or secondary types, because Pokemon without a secondary type are organized into the none category. During the training process, we found that these were the most optimal hyperparameters for both types, which leads us to the final results of our model.
We measured our model's performance through the results we've collected during training and also from testing different new Pokemon. For our baseline model, we decided to go with a pre-trained random forest model, and our test and validation accuracies of this model were as follows. In comparison, our own model performed much better. These values gave us a preliminary idea that our model would perform better, and that the test accuracies confirmed that it indeed was able to keep up its performance with foreign datasets that weren't used for training or validating. Now, realistically, looking at this Pokemon, it is difficult to guess what the secondary type might be. You might guess dark, flying, or even bug type. However, our model is able to correctly predict the secondary type of this Pokemon is fire. Visually, many secondary typings are hard for people to predict even with previous knowledge of the game. So our model is especially valuable since it's able to predict secondary types quite accurately.
Our model is especially accurate when it comes to predicting the secondary types of rock, flying, water, and ground, in spite of there not being as many telltale signs with regards to secondary type Pokemon. It performs surprisingly well for the secondary type of none. In particular, there are many bug-type Pokemon that may be argued to have a secondary type of grass, while our model successfully predicts its secondary type as none. This may be contrasted with similar-looking Pokemon that have primary type of bug and secondary type of grass. A human could have just as easily guessed these Pokemon to be simply of the primary type bug, but our model is able to successfully recognize non-obvious patterns within our training dataset in order to properly classify these Pokemon, and many more Pokemon of different types. Our model is able to recognize meaningful distinctions not apparent to the human eye, allowing it to perform well in not only predicting primary type Pokemon, but also secondary.
Has this ever happened to you? What type of Pokemon is this? Why aren't my fire type moves super effective? I just can't figure it out. Well, look no further because the Artificial Intelligence Pokemon Type Classifier, aka the Poketypeinator, is here to help. All you need to do is give it an image of a Pokemon and it will tell you the type. The Poketypeinator first reshapes the image, then extracts the features, and finally, with revolutionary deep learning technology, it classifies its primary and secondary typing. You could take a random capture from Pokemon Go, or even your own attempt at drawing a Pokemon, and the Typeinator will probably still work thanks to how deep our model goes. Just look at all those kernels. Hey, I think your Typeinator classified this Pokemon wrong. Unfortunately, the Poketypeinator does not account for artistic interpretations for apples nor dragons. However, the Typeinator still does great most of the time. Actually... Still not convinced? Just look at our happy customers. Wow, you're an electric type. Why is that a dragon type? So, you were a water type all along. What are you waiting for? Try out the Poketypeinator today!
So, all in all, this project taught us a lot. We learned that CNNs are best for analyzing images, but also to make use of transfer learning to ease the burden on our computers. Machine learning also takes more time and resources to test and evaluate, as compared to usual coding projects, which meant we had to make smart decisions while tuning hyperparameters and designing the architecture. As we can see, it took almost 14 hours just to train 10 epochs for our model. Google Colab also often kicked us out for running out of GPU, which meant that we quickly learned to save our weights into the Google Drive. We also experienced the struggle of collecting data for machine learning. We had to balance the datasets to prevent skewed results. Finally, we learned that the power of friendship conquers all. Thank you so much for listening, and now back to your scheduled programming.